Hello, everyone. I want to continue with section 5.1, and we'll be looking at these um, final couple of learning objectives. Define and distinguish specific heat and heat capacity, and describe the physical implications of both, and perform calculations involving heat, specific heat, and temperature change. So in this video, we will be looking at some quantitative ways of describing what we had discussed qualitatively in the previous video. So I'm going to scroll down in our book to where we left off, and we will pick up here by discussing some quantitative things. And as always, with quantitative things, we need to have units. One of the early measures of energy was the calorie. And you might be familiar with calories in terms of food. That is actually a little bit of a different calorie. That's the capital C calorie. Is actually a kilocalorie. It is the 1,000 times more than this other calorie that we're talking about. So a calorie is the amount of energy necessary to raise 1 gram of water by 1 degree Celsius. So if we're talking about a kilocalorie, that would be a kilogram of water by 1 degree Celsius. So when you're talking about the calories in your food, that's what you're talking about. We are going to mostly be using this other unit called the joule. So a joule is used in SI units because it is related to other SI units like kilograms, meters, and seconds. This is essentially what it is, kilogram meter squared per second squared. But we will not really be converting to these in this course. This is something you would probably do in the physics course where you're looking at work more so than heat. So for heat, we measure heat with something called a heat capacity, and this is the amount of heat that something can absorb and in terms of how much its temperature changes. So heat capacity is the amount of heat to change the temperature by a given amount. So I want to talk a little bit about how we're showing this. So this is delta T. This is the Greek letter delta. Of course, we all are hearing about delta a lot right now, but in the sense of how we have often used this in chemistry and physics, the symbol delta is used to show a change, so how much something changes. So we're showing this as, okay, heat capacity, how much heat do we need to change the temperature by a given amount? So when you see this triangle, it's the Greek letter delta, and we use it to mean change, often change in temperature. Just as an example, your book here is talking about, well, if you're going to, heat up some food, is it going to go faster in a small pan or a large pan? And you can kind of see how we would do that calculation by looking at, okay, how much energy does it take to heat the pan up for a small one versus a large one? And you can see you could make that distinction by putting in the different amounts there. So heat capacity is something we could use for a particular object. So both of these could have been cast iron frying pans of different sizes. What we will more often be using, however, is something called the specific heat capacity. Okay, the specific heat capacity is talking about heat capacity based on the type of substance that you have and the specific heat of that substance. So the idea here is with these pans, these cast iron frying pans, the difference is because one has a larger mass than the other, but the substances are the same. And the idea here is that it so happens that substances will have the same heat capacity if you have the same mass of that substance. So any sample of iron will have the same specific heat. Any sample of aluminum will have the same specific heat, and we could make the same comparison for pretty much any pure substance. So the symbol we use for specific heat capacity in this textbook is a lowercase c, and this is defined as Q, so heat, divided by mass and the change in temperature. So this is the specific heat capacity. Now, one thing that you'll notice is different in this definition than most of the things we've looked at so far is that it is something that has not just 2 units, but 3 units. We have heat, we have mass, and we have the change in temperature. Just be aware that that will make the math that we do with this a little bit more involved. So here we're showing how we might find the specific heat of, I guess, the small pan. So we have the energy that was transferred. We have the mass of that small pan. We have the change in temperature, and we do all the math to get the specific heat. We could do the same thing with the larger frying pan and notice that they are the same number. Okay, so again, specific heat or specific heat capacity is a property of a substance. And so anything that is that substance will have the same specific heat. And we have a table here showing that. So what do you need to know about this table? You need to be able to use it. So if you have a substance, you might have a question where it says, you know, something is changing temperature by this amount, and you need to calculate something. You might not be provided the specific heat within the question. What you would need to do is know that you can look at this table and look up the substance that you are using, and use the specific heat from this table. I did want to say a few things though about what's on this table. So on the table we're going from high specific heat at the top to low at the bottom, so it's ordered in that way, from high to low. You'll notice towards the bottom we have, oh actually not quite, because we have this one is sort of randomly out of place, the silicon. I don't know why the silicon is a bit out of place, but the rest of them seem to be ordered from high to low. You'll notice that towards the low end of the table we have a lot of metals. So metals have a low specific heat, and what that means is that it is easy to heat them up. Okay, so the amount of heat to cause a change of say 50 degrees is smaller for a metal than it is for other things. You'll notice though that aluminum is quite a bit more than the other metals, which if you've ever had an aluminum powder pan, they take a little bit longer to heat up. The copper pans heat up pretty quickly, and so that's why some people prefer those. And then towards the top, so we've got helium at the very top, but other than that, we've got water. Water has a very high heat capacity, and what that means is it takes a lot of energy to heat up water. To go go up 1 degree by water takes a lot of energy. And that high heat capacity of water is responsible for a lot of very important things for life on Earth, and I'm not going to get into that right now, but I think your book might have a bit more to say about that, so I'll point you to that to look at. And now one thing I do want to look at is that we say water, we're talking about liquid water. For ice and for water vapor, we have different specific heats. So just be aware that that as you change physical states, the specific heat can change as well. But in general, what you want to be able to do is if you're given a question about a change in temperature of a substance, that you would come and look it up on this table to figure out what the specific heat is for that substance. Okay, so what we can do with this information is we can calculate the heat that is transferred when an object changes temperature. So to do that, we would have to know what it is and be able to look up its specific heat from that table. We would need to know the mass of that substance and how much the temperature changed. So you might often be given in the question not a temperature change, but a final temperature and an initial temperature. So what you would do is you would take the final minus the initial to give you the delta T, and then you would just multiply those three things together to get the heat transfer. This calculation of delta T final minus initial is a thing that will continue to come up in this module. So just be aware that that is not a trivial thing, and there will be times where we have to think a little bit about how to figure out in which way is the temperature changing. So there are some examples here. I would recommend that you look through those in your book and make sure you feel comfortable with that. So the first one is finding heat using that equation, but you might also need to find another part of that equation. So maybe you're finding what is the heat capacity, or what is the mass, or what is the delta T, or even what is the final or initial temperature. So you might be needing to find one or the other of those. So there's an example of doing that as well. So you want to become very comfortable with using this heat equation. It is something that we will continue to use and actually build upon in the next section of the module.